Hello, this is Mr. Stansbury. I'm going to take you through the notes on the least squares regression line. At the end of this, you should be able to say, I can calculate and interpret the line of best fit for a data set. So what we're going to do is we can calculate the line of best fit for a set of data by a method called linear regression. Okay, and the linear regression method that we're going to use is called least squares. I will not test you on this. No need to write it down. It's just you're going to see some strange words, linear regression and least squares, and that's just the method that we're going to be using here. Okay, so we're just going to go straight into examples because this is going to be the easiest way to, I think, probably understand this thing. So first thing, we are going to construct a scatter diagram. So what we need to do is construct ourselves a nice little graph here, and really kind of the key here is to figure out what's the range that we're going to have. So we go all the way down to 18 up to 61. So I went up to say 60 right here. 61 will be just above that. And on this we go from 33 all the way up to 120. So made sure we went from 0 to 120 on that. So you got to make sure you got a decent scale. You're definitely going to want to label each one of these here, and it would probably also be wise to give ourselves a title of this thing here. So there is a population, it's population data for wild hedgehogs and frogs living in areas of Ireland. So let's call this hedgehog and frog pops in Ireland. Okay, so to create our scatter diagram, we're going to basically sketch these on here. And whenever you're doing these for the assignments, I just want you to sketch it. Don't go through and measure everything off. So just kind of roughly get the idea, okay? So 44 is going to be somewhere over here in the middle, and we're going to go up to 58. So it's roughly right there. And we just do that for all of these. Let's see. I did that backwards. Supposed to go 44. Oh no, I did that right. I can redo that. Boom, there we go. 44 and 58. So then we do 18. That's 20. So we do 18 and 120. So that's roughly right there. So then we're just going to graph all these points. Okay, so that's roughly what all these points look like. So there's our scatter diagram. Well, now we're going to find the least squares regression line. So what we're going to want to do is get our graphing calculator out on this thing. And what we're gonna use is stats. So we're gonna go into the stats button here, and it gives us all this information. We're gonna want to edit because we want to put all this data in. So we're gonna want to push the edit button. So it's already highlighted on edit, and there could very well be information in there already. To clear out the information that's already there, you go up and highlight whatever list you want to get rid of. So L2, and we hit clear. Now nothing happens right when you hit clear, but as soon as you go down, then that whole list clears out. So then we go over and up, and we want to clear list 1. So we push clear, nothing happens until we go down into the list and everything disappears. So hedgehogs comes first, so I'm going to put that in list 1, and frogs is second, and I'm going to put all that data into list 2. So we will simply enter in all these pieces of data, and then we're going to calculate it. Okay, so once we have all of our data entered in, we're going to want to go back into stats, push stats, and what we want to do is we want to calculate our least squares regression line. So we're going to go over to calculate. So we go over 1 to calculate, and now we're going to go down to number 4, linear regression. So don't try to memorize that it's number 4. Just remember it's the linear regression, right? It's the least squares regression line. So there's the REG for regression. All these other regression lines are for curved lines. We're going for straight, good old linear line there. Okay, so we're going to go down to number 4, and we're going to push enter. And now some of your calculators are going to give you these options here. So you got X list, Y list. So we put all of our X data into list 1, all of our Y into list 2. Make sure your frequency list is clear. I actually shot this video and had to redo this video. This is a redo of the video because I left L2 in my frequency list and it messed up all my numbers, and I didn't realize it until I was all done and already posted. So anyway, make sure your frequency list is cleared for what we're doing here. So it is, and then really all you do is just push enter all the way down until you get to calculate, and we're going to calculate, and it's going to give us all this lovely information. This A here, this is y equals ax plus b. This is our equation of our line. A is going to be negative 1.94. The b y-intercept is 144 about, and then here's our r values. Okay, so find least squares regression line. I'm going to actually write this down. So it's y equals, a is negative, we'll go with, let's just go with negative, we'll go negative 1.94. So y equals negative 1.94x, and then it is plus, let's just go with 144. Okay, so that's the equation of our line. That's our least squares regression line. So we should be able to plug in these numbers here and get something pretty close to that. Of course, this does not make a perfectly straight line, so that's not going to be exact. And we also know that it's not a perfectly straight line because it's negative 0.95. It's pretty good. It's a pretty solid, very strong correlation between the x and the y values here, but it is not perfect, so it will not give you these exact answers. Okay. C, state and interpret the slope and y-intercept for the regression line. So slope is negative 1.94. Y-intercept is about 144, right? And you could put little squigglies to show that this is a rounded number, or you can put equals. That's fine too. But okay. Now interpret. So that means the slope, this negative 1.94. That means I always remember that slope is rise over run. So rise is the frog. So that means you're going to lose about 2 frogs for every hedgehog that you have. Okay, and then also the same idea is if you lose a hedgehog, you will gain 2 frogs because it's going down here. Okay, y-intercept is 144. So if we're at 0 hedgehogs, we should be at about 144 frogs is what that means. Okay, estimate the number of frogs if there were 10 hedgehogs. So then literally we're just going to take this right here, and then we are going to just draw a nice little line. Maybe I'll do a different color since we did all of our data in blue there. We'll do red here. So we just go straight up here. Now it didn't say we should have, it says find, we should sketch our, let's sketch our line on there just for fun. Okay, so this line right here, let's do that in purple. 120, so there's 140, there's about 144, so we'd go about right there. And then we're going to go basically down 2 over 1, right? So if we go down to, say, 44, that's 100, so that's 24. So there's about 44, and then we'd go over about 50. Just trying to get some general idea of what it's going to look like. So our line should look something like that, roughly. And it looks pretty good because it looks like the dots are all pretty close to the line. There's about the same under as over. There's actually definitely more that are above the line than below, but again, it's pretty close. So we'll go with that. So then when we go back to estimating the number of frogs, if there were 10 hedgehogs, we're going up here. It's there. That's going over to about here, so that's about what, 100 and that's 120. So about, let's go with about 130 frogs. Okay. Estimate the number of hedgehogs if there were 45 frogs. So if we're going to do 45 frogs, we'll do that. So here's the frog. So we'll do this in orange. So that's 40. That's 50. So partway through. Now we're at 44 frogs, so we're going to go over until we hit the line and then go down and say about 48 or so frogs roughly. Okay, I'm going to go with 48 frogs. It doesn't have to be, we are, the key word in here is we are estimating. Okay, estimate. So you shouldn't necessarily get the exact same answer as the back of the book. You should be somewhere close, but not necessarily the same thing because our lines are going to be sketched probably a little bit different. Okay. How reliable are your estimates in D and E? So how reliable these are going to be kind of depends on our data. Now this, the frogs one, we went up to 48, and we got to this spot here on the line, right? That is actually within the data set. So this is actually called what you call interpolation. So you're getting data that's inside the rest of the data. So that's interpolation here. And then this first one, the one about, like if we had 10 hedgehogs, it goes up here. Our data starts over here. So that's actually outside of our data range. So that's called extrapolation. And this is interpolation. Okay, because that's gonna come up here again later on. But both of these should be pretty close, and we could even plug these into our equation as well. We were just using our line of best fit that we came up with. Probably, potentially a better way would be to plug it in here. But we should also feel pretty good that these are fairly reliable because our R value is pretty close to -1. If this was like -0.6 something or lower than that, then it's probably not going to be as reliable. But again, since our number is so close to -1 or +1, then we feel pretty good. So pretty reliable. Okay. All right, all we have for the least squares regression line. If you have any further questions on any of this, please feel free to ask in class. Thanks.